In the last video, we finished example 4. Let's move on. Now for this question, which is 1999 CE question. Uniform board of length L is pivoted at a point L over 4 from one of its ends, and the two forces, 14 Newton and 3 Newtons, act on its ends as shown on the right. If the rod is in equilibrium, now find the weight of the rod. Assume that the weight of the rod acts through its midpoint. Again, it's not necessary to make the assumption because the rod is uniform. Okay, now let's draw the free body diagram. As I mentioned before, in this type of question, you've got to work out the different distances. Okay, so the W is the weight of the rod, and it should act at the middle of the rod. So it's got a length of L over 2 from the right end, and also it has got the length of L over 2 from the left end. So the distance between the pivot and the weight is L over 2 minus L over 4, which is also L over 4. And here, the pivot reaction, I call it R. Now, with that, we can move on. Now, we take moment about pivot because the pivot reaction is an unknown force. If we take moment at this point, the unknown reaction R is not taken into account. So the sum of clockwise moments should be equal to the sum of the anti-clockwise moment. This is because the rod is in equilibrium. Now let's look at the forces one by one. Now for the weight W is producing a clockwise moment, so its moment is W times L over 4, and the 3 newtons is also providing a clockwise moment, and its distance from the pivot is 3L over 4. Now the anti-clockwise moment is the 14 Newton times the moment arm, which is L over 4. Now for this equation, we can simplify it by multiplying the whole equation by 4 and then divide the whole equation by L. And we get W plus 9 equals to 14. With that, we get W equals to 5 Newton. Now let's move on to the next question. Now this question is from 1997, the Hanover year, CE. So a light plank of mass 2 meters rests on two trestles, S1 and S2, as shown below. And a boy of weight 500 newtons stands at the middle of the plank. Find the forces acting on the two trestles by the plank. Okay, now let's draw a free body diagram for this plank. Now we call the reaction provided by the trestle S1, we call it R1, and that provided by the trestle S2, we call it R2. So R1 is 0.25 meters from the end, and R2 is 0.5 meters from the end. Now the force 500 newtons should act at the center of the rod. So it should be at a distance of 1 meter from the left end, and also at a distance of 2 meter, at a distance of 1 meter from the right end. So that is distance from the reaction R2 is 1 meter minus 0.5, which is this distance, 1 minus 0.5. Similarly, its distance from R2 is equal to the 1 meter minus the 0.5 meter. Okay, with that, we can find the reaction forces one by one. Now to find R2, we take moment about S1. So that R1 is not taken into account. So sum of clockwise moments equal to the sum of anti-clockwise moment. For the clockwise moment, it's the 500 Newton times the moment arm, which is 1 minus 0.25, which is 0.75. The anti-clockwise moment is provided by R2, and the distance from this point is 1 minus 0.25 plus 1 minus 0.5, which is 2 minus 0.75, and we have 1.25. Now solving that, we get R2 equals to 300 newtons. Now to find R1, we can apply the fact that this rod is in equilibrium, so the net force acting on it should be 0. So this total of the outward force R1 plus R2, which tends to lift the rod upward, is equal to the downward force, which tend to pull the rod downward. But now the rod neither goes up nor down, so they are equal. Now with that, we get R1 equal to say 500 minus 300, and we get R1 equals to 200. Therefore, the answer is B. Let's take a break before the next movie.